In example 2b, we need to test the claim that heights of female supermodels vary less than the heights of women in general. They also told us that the standard deviation of the population of women is 2.5 inches. So let's start with HO and H1. So we're testing the claim that the heights of these supermodels varies less than the heights of women in general. So the standard deviation varies less than, and the standard deviation of the population of women is 2.5 inches. So that's our claim. So the null hypothesis would be that the standard deviation is equal to 2.5 inches. We need to enter the data set into the calculator and find the sample standard deviation before we can find the test statistic. So pause this video now while you do that. And now we can find the test statistic. Chi-square is equal to, the sample size is 18, so the degrees of freedom would be 17. The sample standard deviation that you found in your calculator should be 1.2, rounding to the same number of decimal places as the population standard deviation. And then divide by the population standard deviation squared. So entering that into your calculator and rounding to 3 decimal places, you should end up with 3.917. And now let's find any critical values. Remember, chi-square is a skewed distribution, and from the less than sign and the alternative hypothesis, that tells us that we have a left-tailed test, and alpha is 0.05. So we have 0.95 to the right of that critical value. We said just a bit ago that the degrees of freedom is 17. So use table A4 to find that critical value. And you should find that that critical value is 8.672. The test statistic of 3.917 is to the left of the critical value. Since the test statistic is in the critical region, we reject the null hypothesis. So our claim was with the alternative hypothesis, and we're rejecting the null hypothesis. So that means there is sufficient evidence to support the claim that the standard deviation is less than 2.5 inches.